Example here of a geometric probability. Um, Geometric probabilities are utilized when we're trying to calculate the probability of when will our first successful trial occur. So we're going to, whatever we're dealing with, we're going to start making attempts at achieving some goal, and we're going to repeat that trial until we get one success. This is example number 16 on page 203 in the textbook. It's also in the PDF file that I posted for the class. Shaquille O'Neal makes 54.1% of his free throws. Find the probability that A, the first shot he makes is his second attempt. The first shot he makes is his first or the second attempt. And part C, O'Neal does not make the first two shots, meaning his first success can be anything after the second shot. Remember in this case that X represents the trial on which the first success occurs. Other than that, we need to know our p-value, our probability of success, in this case 54.1%, 0.541, and then our probability of failure has to add up to 100%, so 0.459. The equation for a geometric probability of success on X trial is P times Q to the X minus 1. This is really based on the multiplication rule that we learned in Chapter 3. Essentially, no matter how many trials you have in this case, only one of them is going to be successful. So you're only going to use that probability of success one time. The rest of the trials will be failures, so you're going to use that probability of failure for all of the rest of the trials. So our p-value is going to remain the same for all of these, 0.541, and we'll just drag that right down. Our Q value, we'll go ahead and say equals 0.459 raised to the parenthesis. Our X values are over here in list 1, minus 1. We'll hit enter. And again, in the first trial, we'll have 1 minus 1, and anything to the 0 power is 1. So that should have come up as a 1 there. And we'll just go ahead and drag this down. And there we go. And finally, we're just going to multiply these two columns together. So we're going to do equals that cell times that one. And we'll go ahead and drag that down. Now, you might be wondering, why do I have 1, 2, 3, 4, 5 over here? I wanted to make sure I went further. We really only needed 1 and 2 for this problem because we're only worried about his first and his second attempts. The bottom line is that the geometric probability keeps going infinitely. So there really is no end value to it. It will continue. In theory, the 10 millionth shot could be the first success. Very small probability, but it could happen. So let's go ahead and answer these questions up here. What's the probability that the first shot he makes is his second attempt? So we're going to say, when is X equal to 2? Well, what was our answer there? 0.248. So that was pretty simple. 0.248 is the probability his first success is on the second attempt. What is the probability the first shot he makes is the first or the second attempt? Now, if we go back to Chapter 3, we remember that that word or usually indicates the addition rule. So first or second attempt means we want to add the probability of success on the first attempt plus the probability of success on the second attempt. So we will just go ahead up here until it equals a sum. We'll highlight those two numbers. And there we go. 0.789 is the probability of success on the first or the second attempt. Now it gets a little more difficult. O'Neal does not make the first two shots. Because this keeps going infinitely, our X values can keep going, we can't just do a sum of whatever is above 2. It keeps going infinitely. But what we can do is, since we know he doesn't make the first or the second shot, we can simply subtract those probabilities away from all of the rest. And remember, all of these probability distributions, the sum of all the probabilities has to be 1 or 100%. So to find this answer, he does not make the first two shots. We're just going to tell it to do equals 1 minus And we could either just click on this answer up here, or we could do 1 minus the sum of these two. We could do that again. But either way, we should get 0.211. And these are the correct answers to number 16 on page 203. So I hope that cleared it up. There isn't any other real shortcut we can do. I'm going to highlight these so we can see that these are the answers. Let's give them a nice green color. Seems to green because they're correct, and that makes everybody happy. So there we go. Simple example of a geometric probability, and I'll do another video in just a moment on how to do a Poisson probability. Thank you for watching.